Alright, so we have learned about the two types of reactions, and the first one is exothermic reaction, and the second one is endothermic reaction. Alright, now we are going to focus on exothermic changes. An exothermic change is a change in which heat energy is given out to the surroundings. Alright, always remember exothermic, EX, exit. So heat energy is given off. When an exothermic change occurs, number one, heat is released to the surrounding. Number two, the temperature of the surrounding rises, the container feels warmer. Alright, you need to describe the 2 points. You need to tell me about heat energy. You need to tell me about temperature of the surrounding. For example, when solid sodium hydroxide pellet were dissolved in water, heat energy was given out, right? So based on this observation, heat energy was given out. You can conclude that this is an exothermic reaction. And because of that, temperature of the solution rose. In this case, this solution is actually the surrounding. Okay, so we call this exothermic reaction. Okay, let's try to analyze the graph over here. Okay, pay close attention to the y-axis. It says temperature, even though it's not mentioned over here. You need to know that we are referring to the temperature of the surrounding. You notice that temperature of the surrounding rises. It goes to show that this is actually an exothermic reaction. Right. So the temperature rises until the highest temperature is reached. Okay, this is where the reaction is completed. Because over here, there is no further increase in temperature. This goes to show that the reaction is completed here. There is no further increase in temperature. Okay, and now the question is, why is it that the temperature doesn't remain constant like this? Why does it drop? Okay, this is based on a very simple rule that you have learned in primary school. Heat always travels from a region of higher temperature to a region of lower temperature. So in this case, this temperature is way higher than room temperature. Therefore, the temperature will drop until it reaches the room temperature. Right. So let me reiterate. When the reaction is completed, the temperature of the reaction mixture, which is the temperature of the surroundings, falls until it reaches the room temperature. Okay, but the fact that the temperature rises earlier on, it shows that this is actually an exothermic reaction. Right, so bond making is actually an exothermic reaction. Whenever you form a bond, a lot of heat energy is actually released. Alright, this part here is a little tricky. So we're going to learn about this new term called enthalpy change. Alright, we can actually use this symbol delta H, okay, to represent enthalpy change. Right, enthalpy change, to put it very simply, is actually the heat change. Right, it can have a negative value, it can have a positive value. But for exothermic reaction, delta H is a negative value. Okay, let me briefly explain why. So you imagine this is the before state. Okay, now before, for exothermic reaction, the energy level is high. You have a lot of heat energy. Then for after, so this is after, right? After the reaction, you realize that the energy is now low, okay? Because heat energy is given off to the surrounding. So when heat energy is given off to the surrounding, So this value is actually a negative value. So delta H is actually a negative value. Okay, because it's going down, heat energy is given off. So it's a negative value. Right. Examples of exothermic changes. Now, all these examples you need to memorize or you need to internalize so that you can remember. Okay, let me reiterate that for exothermic changes, we are not just looking at chemical reactions. Some of the physical processes, they can also give out a lot of heat energy. For example, condensation. When you go from gas to liquid, right? This process releases a lot of heat energy. Freezing as well, alright? A lot of heat energy is released when the water freezes to form ice. Dissolving of anhydrous salt. Now you still remember anhydrous? Anhydrous means there is no water of crystallization. Last but not least, we have dissolving of acids. Okay, when you dissolve concentrated sulfuric acid in water, you also release a lot of heat energy, right? And therefore the temperature of the surrounding rises. Alright, now let's take a look at the chemical reactions. Okay, combustion of fuels, rusting of iron, corrosion of metals, neutralization, right? Reaction between acid and alkali, respiration, all this, they release a lot of heat energy. Temperature of the surrounding rises. Okay, pay close attention to neutralization and combustion. And for respiration, all right, this is very interesting. Okay, if you don't believe me, everybody, you take a deep breath in and then you breathe out. Okay, you realize that your breath is actually quite warm, and that is because during respiration a lot of heat energy is given off, right? A lot of heat energy is given off, and therefore respiration is actually an exothermic reaction. Examples of exothermic changes. Neutralization is an exothermic reaction. Okay, so for example, sodium hydroxide reacts with hydrochloric acid to give sodium chloride, which is a salt, and water. Alright, so this is the chemical equation. So this is the chemical equation, and this is the ionic equation. So the hydrogen ions come from the acid, the hydroxide ions come from sodium hydroxide. Alright, they react to form water molecules. Heat energy is given out and the solution gets warmer. Right? The solution is actually the surrounding. So the temperature of the surrounding increases. All combustion reactions give out heat energy. Right? Methane reacts with oxygen to form carbon dioxide and water. So this is an exothermic reaction. It gives out a lot of heat energy. Okay, which process is exothermic? Okay, the answer is A. Remember, combustion. Burning petrol is combustion. Combustion is exothermic. Question 2. Which one of the following processes is exothermic? The answer is B. Okay, because you go from the gaseous state to the liquid state, so this is actually condensation. Condensation is actually an exothermic reaction.